Hi, everybody. It's Patrick Piscolis with Banyan Technology Tire Tracks, our presentation of the look of impact of AI on freight procurement with part of our mini series. And I have with me Roger Boza, the Chief AI Officer over at CloneOps.ai. Roger, how you doing today?
Good, and thank you, Patrick, for having me here. It's a pleasure to be on the show with you.
Is this when you tell me that this whole screen and picture is just AI created and this is nothing of what you look like?
We're heading in that direction, but I can tell you is we got an assistant right here. His name is Badass. He's going to be pretty soon taking over my meetings and responding as if it was me.
I like that. I like that a lot. So let me start by, as we're looking at AI specifically within logistics execution here, from a pure AI standpoint or even just background standpoint, Roger, who are you? How'd you get into AI? And what is CloneOps.ai for anyone that hasn't heard of them or maybe has and just doesn't know exactly where you sit?
All right, so let me tell you a little bit about my background. I have a bachelor's and a master's in computer science with a track on software engineering.
So you definitely know how to tell people to turn it off and on again.
Yeah, and usually if something is not working, my recommendation is turn it off, power it back on, hit it with a hammer. If that doesn't work, then call IT.
That's right.
At the moment, I'm actually finishing up my PhD on artificial intelligence, both computer vision and natural language processing.
So where do you get that from? Is it from Miles Dyson over at Cyberdyne University? Like, well, and that's a Skynet T2 reference for anyone that isn't that nerdy.
No, it's my university here in my hometown, Florida International University. They're not very well known for AI, but they do have a track and a department in there. In fact, they also have a department called the Applied Research Center, which focuses on doing AI solutions for the industry. Not necessarily this one, mainly the Department of Energy and Department of Defense. And that's how I started doing a little bit of my work. Actually, for the past 7 years before joining CloneOps, I was doing AI automation and workflows in the nuclear industry.
Wow. Okay, so a lot to unpack there. One of the things and thank you for joining us, because a lot of the people that I'm talking to for this mini series already have a freight background, but probably don't have the AI background and the chops that you have. So first, I want to start with how is there a difference, maybe at that master's level of computer science versus the PhD into AI? Are we just looking at prompts all day, or what are we getting into that makes this so in depth? And what do you love about it?
Yeah, so there's quite a big difference between master's and PhD work. So at the master's level, somebody is very specialized. They're really good at doing implementations. They understand the theory. They can develop applications for it, but they don't necessarily understand completely, right, at a very foundational level, the inner workings of artificial intelligence.
Gotcha.
Right? They know the pillars, right? Artificial intelligence is composed of a couple of things, like linear regressions, which is, mathematical models for that, predictive analysis, deep learning, machine learning. So they get exposed to a couple of the methods, the ideas, the algorithms in there. But once you transition to PhD, you select a very specific problem. Usually you try to advance the field forward, and you basically research for 2 to 5 years your proposed solution.
And as we go in, and I'll have some logistics-based questions, CloneOps.ai, where are they positioned? What are you doing now? Because like we talked about, you're not necessarily in the freight execution piece of it, but more of business. Where do you play? Where's your niche?
Correct. Yes, we focus on business communication. So
it's not logistics.
No, but it is in the logistics. So business communication from the point of view of, you can imagine you got a broker, you have an influx of calls or an outflux of calls, right? Depending on what scenario we're talking about. Right. But let's say you had a carrier sales rep doing rate negotiation and load booking. And on a typical day, they get a load, they'll go to a load board, they'll post it online. And immediately, and I've seen this in person, as soon as they post it online, you get 5, 10 calls, one after the other. So what your CSR is going to do, he's going to pick up the phone for the first one, right? He's going to start talking, trying to negotiate a rate.
Mhm.
Hopefully, right, the goal is for the first carrier to call to actually negotiate the rate. But most of the time that doesn't happen. You waste 3-4 minutes talking, negotiating. You hang up, you go look at your caller ID, you're going to call back the second person that called to see if you can get some capacity in there. And he's angry, he's frustrated because you didn't pick up. He might have found another load, call that broker, and it's just a back and forth, right?
Yeah.
Eventually, all the stars align, you get somebody, they'll move the load for you. But here's where CloneOps comes in, right? We're
Right.
using agentic AI, and for this scenario, rate negotiation and load booking, you're gonna get a virtual agent to respond the phone. So no
Okay.
more missed calls, right? It will
Sure.
respond for everybody calling in. It
Love
will
that.
verify you, right, to see if you're approved with them.
Right. If you're a real person. Yeah.
Yeah, yeah. And I'll talk a little bit more about that because we're doing something for fraud with technology we're calling voice ID.
Okay.
But we'll talk about that in a little bit.
Yeah.
So the agent picks up, right, starts negotiating with you. And if it comes to an agreement, it books the load on your behalf.
Ah.
And if it doesn't, we have the capability to log that as long as we have integrations with the TMS they're using to log
Right.
that capacity in their systems.
No, and that's awesome. Both from integrate with Banyan and TMSs like that. Please offer more value. That's a very selfish and biased approach. But as a salesperson, I've lived that life. Not even on the carrier side, where I got to answer every phone call that comes in. Doesn't matter if I know the number. Doesn't matter if I've been calling people. Every number that comes in is an opportunity for a commission or a deal that I might just be waiting on that call. So that speaks to me a lot. And I think that that's not necessarily, sure, there's an application within logistics, but that's almost across the board anytime you're going to have phone conversation interactions that way. Now,
Yeah.
tell me this, and before we get back into more logistics, I want to go back in a little bit into your expertise and AI. Now, at the PhD level, are we talking just more of these learned language models, or are we starting to get to that point of actual computer sentience, or where that line is going to be crossed soon? What does that look like from a sci-fi nerd to a logistics freight guy, to Roger, who is getting this information at the highest cutting edge level?
And I love that question. And I heard one of my favorite keywords, which is sentient AI.
That's right.
Yeah. My opinion, we're still quite far from sentient AI, right? Right now, what we have, our entire artificial intelligence framework revolves around probabilities.
Okay.
So all the models are trained on the data set, and whether they learned, a function to predict the value correctly, because we have some labeled information. We know
Yeah.
the input, we know the output. We can get some mathematical models in there,
Sure.
to model that distribution. Where machine learning and deep learning kicked in is instead of us having to tell it what to pay attention to, what to learn, what features to extract, deep learning and machine learning extract that information at a basic level by themselves.
Okay.
So we're not
Okay.
telling it. So, and I'll give you an example. Let's say we had an image
Yeah.
and we want to know if this image is of a cat and a dog. It's one of the simplest hello worlds in the field.
Right.
Normally, as a human being, you're like, all right, I know that's a cat because I see the fur, I see the pointy ears, it has a long tail, it's very small.
Right,
Well,
but
you
to your
start paying
point,
attention.
they're both four-legged, they both have tails, and they both have ears, and are equally about the same size. So from a pure, just if I'm doing bullet points, they have so many in common that's up to the perception to define.
Agreed. And in fact, if we actually give a human being about 10,000 images of cats and dogs, they'll get roughly 80% correct.
Okay.
So some cats are going to start looking like small dogs, and I've seen some of those
And those
examples.
dogs that you're keeping in the purses start looking like cats. Yeah.
Yeah. Yeah. So deep learning and machine learning really have an advantage there because we're not telling it what features to pay attention to. Basically, the way that we train them is here's 10,000 images. I'm going to let you know which one were cats, which one were dogs. And it goes through an iterative process. And what it does is during those iterations is if it gets it right, nothing changes. But if it gets it wrong, it goes back and it updates the neural network.
and it learns, right?
And quote unquote, that's how learning happens. It's updating, tweaking the knobs in the computational neurons in the network.
How would something like that, which it seems impressive, apply to logistics? If we're telling the difference between cat and dogs, what kind of things could that? Here's 10,000 shipments. Here's what's a good one. Here's a bad one. Now I want you to go find rates for the shipment that I need to move tomorrow and tell me if it's a good price. Or where does that have application? And maybe that's not it. Maybe that's just the low hanging fruit. How do you see it as a person who, I'm sure ideas are blooming left and right of where you can fit AI into just about everything that we do?
Great question. And I got a really good example. In the field of computer vision, which is what I was describing,
Yeah.
you got document classification, right? So you might get an email. It might have a raycon, a bill of lading, an invoice, a receipt.
Might get an email, get a million of those emails for sure. Go on. Now you're talking our language.
They're in the order of hundreds.
Yeah.
And what you want to do is you want to understand what type of document that is, right? Because if it's a receipt, I want to extract certain information for it. And that's where another part of AI kicks in, which is called optical character recognition. That way we can pull out contextual and textual information out of images. But you still need to know what type of document it was before so that you have a baseline of what you want to extract.
It's not learning on the fly from nothing. It's got to have a core there to begin with. And then from that, it can build upon it.
Correct. Yes. And that's another key point of machine learning and deep learning, which is called knowledge transfer. Normally, you start with a generic data set, right? That's a whole bunch of images of receipts, bill of ladings, proof of deliveries. So for document classification, but it doesn't have to start with documents from the industry. It can be in general. What you do afterwards, and this is called fine tuning or knowledge transfer, what you do is you have this base model. Now you give it the data appropriate for the industry or for the scope, and it learns now to specialize within those documents.
Yeah, and that brings a question or maybe a concern. So if we're feeding it all this information, does it have to be? And I think this is one of the early debates or friction points of AI. How do you get it all this information from anywhere you can without taking other people's, proprietary information? How do you feed it with real enough data that, because the public space only has access to so much to grab and do with what they want. Just about every, 30, 40% of it has someone's IP or trademark stamped to it. And that's really what you want it to know, though, because that's where people are investing and putting private dollars into. How do you differentiate? How do you marry those two trains of thoughts? I got to protect my information, but I also need this AI to have as much information as it can, or it's not going to be as worthwhile.
Yeah. So the first way to tackle that is stay away from public models, right? An example here is, the general OpenAI ChatGPT model.
So don't drop my entire share drive of my company files into ChatGPT and tell it, hey, you're my new bot. You're going to do work with me.
Yeah, it's going to work amazing. It's going to do what you want, but you just gave OpenAI, the right to use that data to reach.
You're going to have an HR conversation coming up pretty soon.
Oh, yeah. You're going to run into some legal issues as well in there. But what you can do is, you can grab offline models, which means they'll run locally. Some models are small enough for you to actually do that, within, the typical computing power that companies have. Other models are too big.
Right.
ChatGPT is way too big to run locally. You need a cloud service for that. But you can request a service and it gets pulled off of their production environments. It goes into your own clusters. And whatever data you put in there now is privately to yours. It will not be used to train models that are open to the public or shared across a network. Now, just to expand a little bit on that, because there's a couple of tricks, right?
Yeah, I was just saying, that was pretty simple, but I know you've got some nuance to it. Please.
So let's say that you don't have enough data, so machine learning and deep learning is all about big data. The more information you have, the better the networks learn.
That's right.
The more they can generalize, the more robust they are. But let's be honest, right? A lot of times you don't have a lot of data. You might be a startup company. You might have only been in business 1 or 2 years. You might only have 500 documents instead of 50,000 documents. So there's another technique is called data augmentation. And what that does is it's another AI model, but this one is a lot smaller. And what it can do is it can learn the data distribution of your 500 examples and it generalizes. It generates from
Okay.
within that data distribution, it generates new samples for you. And what you can do now is you can use these new samples and train the network that you want.
So if you've got the data, you can use it all there and use it to great effect. But if you don't, it doesn't mean you're SOL. You can use AI to kind of pump that up. And then as you get more data, continue to build upon that to get better probabilities, like we talked about at
Correct.
the end of the day. Okay.
Yeah. And you're probably, familiar with this. Have you heard of the service called Midjourney?
I have not. Tell me about that.
So Midjourney was a service. I mean, they were pretty cool. Cool. They were one of the first ones to actually impress me. You can give it a sentence or a paragraph, and it would generate an image based off of that. So we got text to
Oh,
image. So let's say that I want, to start classifying,
like a good-looking bald podcast host, right? That's and
and we use
see
we
how
use
close.
you
Yeah,
right now. We use
yeah.
you right now as our prime example. So Midjourney is a generative process of taking text to image. So if I
Okay.
was limited in some information, I can use one of those services, generate hundreds and thousands of images, and use them now to train my model, fine tune my model, make it a little bit better, gaining some time so that I can acquire original ones and merge everything together.
And then you're also like, to your point, you're not going out and grabbing somebody else's protected data. You've generated all these to start that. Okay. That makes sense to me, which is great because I assumed most of what you said would go right over my head. So I'm happy about that. Now we talked about AI within logistics on on the conversations back and forth on the rate, getting emails on the rate count and being able to do it from there. What aren't we talking about in the logistics space that we could be doing with AI? I know that you're talking about next steps or man, what if we did this? What could logistics and freight be doing with AI that we haven't really gotten there yet, or no one's been creative to start thinking it through?
I think there's been some conversation about what I'm going to say, but it's definitely where I see the industry going.
Okay.
And that is AI talking to AI.
Okay.
So from our examples and our pilots, what we notice is we got a virtual agent, right,
Yeah.
representing a use case scenario for a broker. Now the carriers are going to get a whole bunch of calls.
Yeah.
They, they get frustrated. They're picking up the phone. They're talking to virtual agents, and they have a need now to have a virtual agent to respond for them. So at that point now, you have a virtual agent on one side at the broker, you have a virtual agent on the other side, the carrier, and now you just have, AI talking to AI.
And
At
at the
that
end of
point,
the day, the email gets to the right person to say, hey, load this up or get a truck out here.
correct. Yes. So there's three main communication mediums,
Okay.
right? You got text, you got email, and you got voice. And a lot of the transactions happen across all three. You might get a
Right.
phone call to, start negotiations. You might get
Yep.
a text back because you couldn't respond right away, or track and trace. All right, here's my update. This is where I am. And then at the end, you might get through email the bill of lading, the proof of delivery, whatever
Yeah.
else goes there. So you got three modes of communication, and what AI can do is bring them all together so that it's aware of the whole context from a general point of view, and it can
Mm-hmm.
engage in communication. And at this point, communication is just the exchange of information back and forth. You don't really need voice at that point.
No, and that makes sense. But here's where I like that I'm talking to you because I want to talk about what could be a negative repercussion from that because I see the benefits and how that could work. But now we have AI talking to AI. And isn't the fear that they develop a language that we can no longer decipher because they find it more effective to talk in that language than the language we've taught them?
Yes. And I think you kind of got the hint there where I said voice is not needed anymore. Right.
They're
But the
talking in ones
essential,
and zeros and blips and blips. And I'm going, man, this is the weirdest Morse code conversation I've ever
yeah,
heard. Yeah.
and that's where I was heading, right? All communication is going to be digital. So at the end of the
Okay.
day, it's ones and zeros. Normally conversations, and in this case, communication back and forth, follow a protocol. It's a standard way for two agents or two mediums, right? Or two different endpoints to communicate, but they agree on how the exchange of information happens.
Okay.
That protocol right there might be AI to AI. Like I said, it doesn't have to be voice. It doesn't have to be, human readable language,
Right.
because it just takes more information to store it and display it. It is going to be simply the ones and zeros that communicate back and forth. But I still think that you need AI, because you have, the benefits. You want somebody to represent your own interest. That will be your AI. And then
Yeah.
you're communicating with another party. They have an AI to represent their best interest. Now, communication just happens in between.
And with that, and I do get that, and I like it. Now, will there be in this world where the AI are talking to each other? There's going to be a receipt somewhere, right? Either on the local server or on a cloud of this conversation. So at the end of the day, someone goes, "How did these two systems get to the point of, hey, we're going to do it for $300, and I'm going to have a truck there at 7 a.m. tomorrow?" Is there a ledger someone can refer back to? And again, because it's logistics, a mistake is going to happen somewhere along the line, and be like, okay, where do we circle that and make sure we don't do that in the future?
Yes, I agree. And normally that happens at the observation level,
Okay.
meaning you might have a dashboard that is collecting, aggregating all of this information. It might be by, event ID, or it might be by conversation ID. But
Okay.
there's always a log, a transcript of everything that has happened between all parties in the communication.
Right. Okay. And that makes sense. And I think there, and much to the theme of logistics and AI, that's where you'd want a person. You don't want AI watching the two AI for oversight, much like, I don't want me and my sports team to be the one telling the ref what to do, because inherently I'm extremely biased and I have no reason to necessarily do the right thing for all parties.
And that's actually something that happens with large language models. They get to be a little bit biased. And bias is introduced either, when you give it the data to learn, or the way that you structure the neural networks and the outputs when you introduce another human bias. And what ends up happening is it's going to make predictions that favor that bias.
And when you say bias when it comes to AI, is this just, I'm going to lean to make these guys be my good guys? Or is this almost a bias in perception that, hey, if whenever you turn left, it's wrong, you should always turn right?
I think it's both. And I'll
Okay.
take it back to the example of cats and dogs, right?
Yeah.
If I gave it 9,000 images of dogs and 1,000 images of cats, that model is going to be way better predicting dogs than cats,
Yes. Okay. So it's almost
because it
it's almost
saw
a
more.
data bias.
It's a data bias, yes.
Okay, that makes a lot of sense. So, how does somebody say that I'm trying to use AI in logistics and I want it to be as accurate as possible? How do I avoid a data bias?
You try to make sure that your data is balanced. And
Okay.
let's take it back to that document classification as an example, right? Maybe we gave it 10,000 receipts, we gave it 100 BOLs, and we gave it 5,000 PODs.
Got
That
you.
model is so AI will always make a prediction.
Hmm.
Usually there's a probability attached to it, or some sort of confidence as well, if the engineers and the models can support it. So what happens there is you're always going to get an output, right? And if you just, it's like, hey, I got AI, I'm going to turn my back and I'm going
Yeah.
to let it run by itself, it's going to make errors. Now,
Right.
the errors, right, those wrong predictions
And
are going to
humans never
happen.
make errors.
Oh, not at all. I wouldn't say that.
No, no. And please continue your point. I'll remember that for my
Yeah.
next question.
So, you start getting errors. You always need, and that's a philosophy we have here at CloneOps.ai, always have a human in the loop. Not for the repetitive tasks, let the AI handle that, because that's what they're exceptionally good at, but at exception handling. Things are going to go wrong. You just need a way to catch them.
I'm smiling because that's an amazing thing, because that's what we talk about with the use and the real function and end day goal of a TMS or software in general. 80 to 90% of it is the nothing has happened different. It is the bread and butter. And then you still always have to have that 10 to 15% that, hey, the world is on fire. This didn't get where it needed to. So I got to make sure I'm paying attention to that. And the only way I can do that is knowing the majority of things is being handled by a technology somewhere. Otherwise, I got to have way more people involved than I probably have the payroll for.
Yeah, and what you want is some analysis in there to help you as the human in the loop to know when things are going wrong. So in our case, for our conversations, we have a conversation score. Right?
Okay.
That's a metric that is composed of three different analyses. We will analyze the text itself because going from voice to text is a transcription. So I have text
Right.
information.
So make sure see what errors could happen at step one right there.
Yeah. So what I'm doing is this conversation at the text level going positive, neutral, or negative?
Correct.
Right. That's a sentiment analysis.
Mm-hmm.
And we'll take it a step further. How is the mood of the conversation? Is the in this case, it's a customer, but it's a carrier. It could be a dispatcher.
Yeah. Are someone saying, "Yeah, I really like working with you," or someone's talking about all the expletives about why they didn't like what happened? Yeah.
Is the mood in the conversation at this point in time? Is it angry, happy, sad, frustrated? And that relates to somebody dropping an F-bomb in the middle of a conversation because they got frustrated.
Right.
But that doesn't capture everything. So we have a third metric, and it's the voice itself, the audio. We analyze the audio to see if you are screaming, whispering, if you're rushing through your words. Are you speaking normal? And what we do is we combine all three of those into a single number, right? This number is going to be between 0 and 100, and it's going to let you know how that call is going. Now, whether it's something goes wrong because the virtual agent made a mistake, maybe had wrong data because somebody entered gibberish in the TMS and we pulled it from there, or maybe they're just not understanding each other or they're not agreeing. So that should drop that conversation score, and we can capture that with the sentiment, the mood, and the tone of the voice. Makes sense. What you want to do is you never want to turn your back on the system and just walk away and let it work. It's going to work maybe 80-90% of the time with the scenarios. But that conversation score allows you to now monitor the calls, sort or filter by it. And if a call is going bad, here's where the human intervention comes in. Go ahead and take over that call and mend the situation.
Now that makes a lot of sense to me. And it sounds like those that are doing all of these fine details of execution in kind of your world or where AI is involved, are going to pivot to more of a management role, but not necessarily of managing people, but of either managing AI or of the rules and the analysis that's happening there. So you can do more, but you're still there. You're still at the dashboard. You're still at the controls, as it will.
Yeah, and that's usually an organizational structure that changes. Right? AI is not just replacing jobs. It's a tool. AI is a tool. It lets you be more effective. It lets you have higher throughput. It lets you scale very fast. But now you need new roles to do additional things because you're engaged in AI.
So it's not coming for your job. It's very much the automation in the manufacturing lines where you might need a pivot from putting something on and off the line and figure out how to manage these robots doing it or how to build the line itself. It's not necessarily taking your exact job, but you may want to look at how you can be the one managing the new technology.
Exactly. Yeah. Humans were very good at creative thinking, right? And problem solving. Usually
we also create those problems. We're really good at that.
Yeah. We can invent a problem and we can drown in half a glass of water.
That's as growing up, someone always used to say, Patrick's really good at talking himself out of trouble. He probably talked himself into trouble too. But yeah, no, I
see that happening.
Yeah, I like that call out, and kind of at this where humans are creative and at problem solving. Let me go back to this thought I had on errors. So we're replacing some of the human interaction and some of the human execution, which inherently has errors in it. The AI and all of the language models and the different AI communication are also going to have errors. Is there a different level of acceptable errors that we're going to perceive, or by the nature of the technology, it's always going to be less or it's always going to be more?
So in my experience, once you have good AI models, the error rate is a lot lower. And that's part of the process because we would train models, compare them to a bench line where we know how humans perform, right? So let's say the humans were performing 85, 86% accurate on this benchmark. We will
Sure.
aim for something higher than that. And AI usually takes us to the mid high 90s.
Okay. And when you say good, does that mean it's been doing it long enough? Like what is it, having it in place long enough or having the right amount of data? What makes, or is it the actual engine that it's built on? How do you define a good AI versus an AI that's not good enough?
Yes, and that is
That's
a
another
very
great hard question, I'm sure.
yes,
Yeah, not an easy
yeah,
yes or no, right?
yeah,
That's why they paid me the big bucks.
And so that's usually a threshold that is set either by the engineers based on business insight or an entire industry. So I'll pull in a little bit
Gotcha.
of my background, right, coming from
Mhm.
the nuclear side with the Department of Energy.
You see,
Uh,
you can't have bad AI when nuclear is involved, right? Like, yeah,
yeah,
the opening or the window of error has to be minute comparatively to a lot of other industries.
exactly. That's what I was going to say. In that industry, those solutions are considered critical systems. So you're aiming for 100%.
Right.
Now, here's the caveat. AI is never 100% because it's probabilities, right? What's the probability of me predicting a good outcome?
Even that 99.999% still has that 0.00001% that lives out there. Right.
And at that point, you usually want a fallback mechanism or you want some sort of explainability to catch and have the AI explain as to why it made that prediction or that decision.
Hmm.
But for most other industries, right, they're not critical systems, so you don't push them that high.
Right.
And it's a diminishing return what you get out of AI. So let's say you
Okay.
had a model and it was already at 95% accurate. Getting it to 96% might take you, let's say, a couple of weeks. Getting it to 97 might take you a couple of months.
There's an exponential demand for time and effort once you hit a certain point, is what I'm hearing.
Yes.
So it's almost this classic: perfect is the enemy of good, right? Or
Exactly.
better is the enemy of good enough. Because if you get it to a certain point, that's as good as you're going to get it, and have a human being there to be ready for it. Because otherwise, you're investing another 5-6 years and quadruple the resources you did just to get to this point. Okay,
So, and I'll give two examples so that we can put some context into this.
please.
Let's go back to the document classification.
Yep.
If I were to design this, right, and you are, my boss, quote unquote, is like, hey, Roger, we need this to work as good as possible. I want this to be perfect. I'm gonna come back to you and I'm gonna tell you, nope, let's be real. Are
Yeah.
you okay if the AI classifies 97 proof of deliveries correct out of 100? Are you okay with three of them being wrong? We will catch it with a redundancy system, and now we have the human intervention. We go in and we manually fix those. Are you okay with that? If you tell me yes, then I'll set that as the criteria for the models. That will be its accuracy. If you tell me no, then we're going to have another conversation where I might have to explain why going with higher accuracies are going to be difficult. Maybe we can push 98 or we can push 99, but that's where the engineering comes in.
And Roger, I think you just hit on a point that comes up with everybody I talk into logistics, is that no matter what technology you put in there, whether it's basic automation, integration, or now as we're talking some complex features of AI, it's that nothing can get done or get done the right way without a human understanding of what that goal is,
Yes.
and that relationship there. Because like you said, Roger, make it good. Okay, I'm going to need you to define what good is. Does that mean 1 out of 3? Does that mean 1 out of 10? Because without that, your good is all right. Here's 50-50 ball is
Yeah.
not the same as what they, and if you don't have that conversation or that relationship, it doesn't matter. It's not going
Exactly.
to work.
So what we want is an objective metric, something
Okay.
that has no opinion on it. Because hey, this is good. That's just an opinion, right? I
That's really
use
tough to do. You're talking logistics. Everybody has an opinion, and they're all going to tell you whether you want to hear it or not very loudly. No, so
so
this objective base. Yeah, go ahead though.
yeah, and I'll give you the other example because the one that I explained is for computer vision, but it also happens with natural language processing. In the case of CloneOps, right, where we have voice AI for conversations, what we would do is here's an agent, here's a use case scenario.
Yeah.
Let's go back to the rate negotiation and load booking. I'm gonna
Okay.
give it 100 test cases. And if it successfully negotiates on 97 of them or 98 of them, I'm going to say this is good.
Correct.
So that criteria right there, and I think that's where, companies and decision makers, they have to sit down, and have a conversation about it is, what is our acceptance criteria for this to work? What are the
Okay.
KPIs to know that this is how we want it, and we will mitigate the rest?
I like that. I like that. It's almost calming to know that we'll still be needed as a species during even most of the robot takeover. But and jokingly, but to a more serious question for you is, as you're going through this PhD, as you're kind of delving into this, both from a professional and what sounds like kind of a personal curiosity and passion side, what excites you the most about what AI can do? And on the other hand, with the devil on the shoulder, what is your biggest concern of what happens when we get AI to a certain point?
Yes. And I think I can answer that based on how I got interested and my curiosity for AI.
All
I was
right.
playing video games, and maybe you heard of this one, World of Warcraft.
Hold on. We could have I am an original vanilla player from '05. I have played
Yes,
I am
sir.
now playing Anniversary Edition. We're going to exchange contact information after this because nobody needs that kind of nerddom. So go back, just loving
So
that you're a WoW player.
I started right at the end of Vanilla, going straight into the Breath of the Lich King. But what happened was, I jumped into the game by mistake. It caught my attention, started playing it,
Okay.
and it was consuming a lot of my time.
Oh yeah.
Right? To get the next resource, to get a better pair of boots or a better, garment or a better sword, better shield,
Right.
I had to play weeks. And I was like, you know what? I got programming skills. Let me try to automate. And by the way, there's a difference between automation and AI. So my
Right.
first attempt was, let me try to automate what I'm doing so that it can play by itself. Because I want to go do other things, right? I don't just want to
Sure.
play. I want to enjoy the end game. But getting over there, I don't want to spend weeks trying to get it done. So
Hey.
let me automate this. And within a couple of minutes, it looked like crap. I was like, all right, I can tell that that is a robot. Somebody's going to see me. Somebody's going to report me. They're
I'm
going to
getting kicked off. I'm breaking the terms of service, and it's easy to see from a mile away. Yeah.
So I started looking a little bit more. How do I make, my character move, fight, collect, behave more natural as a human being, as I would be playing it? So I tried with equations. I tried with models to replicate what I was doing.
Okay.
And that is the essence. That is the nature of AI.
I love so much that the core of your entire AI professional career comes from World of Warcraft. We will definitely be talking about this outside of this podcast.
I went for sure. I went back to education to learn now the foundation of how to actually do AI.
That's awesome.
One of the difference at the PhD level is I don't necessarily just have to go and use a ChatGPT model, right? And I should say a large language model. I don't have to use what's out there. Or for computer vision, I don't have to use the models that are out there open source. I can create my own. So usually what I want is the smallest model so that it doesn't consume a lot of resources, both computationally and
natural resource wise. Yep.
Yeah. So you want the smallest model as possible, but that it gives you the accuracy that you want. Now, what's available out there open source usually meets one out of those two.
Okay.
So here's where I come in, and this is one of my roles at CloneOps. I will develop the new technology if what's available out there is not worth it, business-wise for us.
Right. But it's a if it ain't broke, don't fix it. But if there's nothing there, let's come up with something.
Yeah, I don't like reinventing the wheel, and I don't like shooting a bazooka to kill an ant.
Right. Right. So with that and understanding where you come from, what's that highest peak and what's the lowest low of what AI could do both ways?
So the highest peak is, considering it as a tool, it gives me my time back. And the only thing we can buy more of. Never get back is time. Right. So that's my favorite thing about AI. It gives me time back. And in my case, I usually will use that so that I can spend more time with my family or doing other activities that I like to do.
Heck yeah. All right. So what's the flip side?
On the opposite side, what scares me the most is when one of these models make a prediction and the model itself is not explainable. So we have no idea why it made that prediction.
So this
Because
jump
there's
in logic or probability that we can't track.
yes, that's the problem. So at the basic level for
Okay.
AI, you can have something as simple as a decision tree.
Yeah.
If it's the weekend and it's sunny and I don't have to work, I'll go to the beach. So
Right.
if we end up at the beach, we know exactly why because it's a
Okay.
decision tree. We can follow that path.
Right. If A, go to B. If B, go to C. Right. It's like the geometric proofs that they made you learn. And you're like, why am I writing in a math class? Yeah.
Exactly. Yeah. But with large language models and computer vision, which usually you need neural networks, you have millions and billions of parameters in there. And each one of them is like a trace, is a jump, it's an if.
Yep.
From the human context of this, look, I have a hard time understanding 20 conditional statements as to why we made a decision. Can you
let alone
imagine how
100, let
millions,
alone
billions, and
1,000, let
trillions?
alone a millions and billions. Yeah.
So we can always go back and say, well, clearly it predicted this because we gave it this input, and here's everything that happened. But if I ask you now, put it in human terms, what actually happened? We're like, hey, no, we're stuck there. So that's the part that worries me a little bit when some of these models make predictions and we have no idea why. Because it also ties to another concept. GPT, it stands for Generative Pre-trained Transformer. That first word right there, generative, it means that it can generate new data.
It's
And
creating.
you want that. It can create. You want that. If not, things are going to sound very robotic. It's going to sound like pre-recorded calls or pre-recorded audio. So you want it to generate for you.
Sure.
So, but as soon as we give it the ability to generate new content, that means that we're introducing randomness, and that's where explainability starts being hard.
All right. Okay. So Roger's against entropy. All right. No. But yeah. No. It
don't quote me on that because my PhD thesis is in entropy, and that's a whole nother topic. And we might need like 5 series on a podcast to cover entropy and information theory.
No, that's a great call out. But I think that's a very important call out and fear or concern there, because again, it goes back to almost one of the first things we talked about, that even as those AI could be talking to each other, there's a receipt somewhere. You can follow the logic. You can understand where it came from. But the second it's in a black box and you can't see that, that's something to be concerning. Whether from a business sense or a morality sense.
I think you have been reading or hearing about deep learning because you said another keyword, black box. And true enough, that's actually the term that we use for the model itself, the architecture between the input and the output. What's in the middle is a black box.
And that's just AI, man. And here's what that's just sci-fi as far as growing up reading the greats. And I think one of my last questions will be, as you're looking at these cutting edge technologies within AI, as you're messing with things in your PhD class that most of us probably can't comprehend, are ideas like the Asimov rule of 3 being input, or are these kind of the Wild West? And for anyone that doesn't understand, these are basically the 3 rules of science fiction robots: is that 1, you can't harm humans; 2, you can't harm yourself. And if you have to harm yourself to save a human, you're basically doing that. Like, what parameters are you putting in? Is it as simple as 3 rules, or is it as big as like a Bible or a dictionary that someone's got to load up into? How are you, for the lack of morality and human perception, how do you encompass that into a technological piece?
Yeah. And
I know you have no one-way answer on this. I knew I'd have to ask a real hard one for you, because you're way too smart for me. So I had to stump you and make it tough for you a little bit.
What I can tell you is that that's actually 2 fields. One of them is computational science, and the other one is philosophical.
Oh, yeah. That makes sense. Sense. That's where I waste a lot of my time, is the philosophical. Ask my wife, why are you thinking about that? That has nothing to do with us. I don't know how not to.
Yeah. So from the computer science side out of this, yes, we can always put in so code when we write, program, syntax, script. Yeah. It's deterministic. Given the same input, when you execute it, it will have the same output.
That's the computational side.
Randomness in there.
Yep.
So from a programming point of view and an AI point of view, if you have a system that is deterministic, yes, you can put those three rules, right?
Mhm.
Human life is precious, preserve it, and help it.
Yep.
But it's kind of like a two-sided, sword here.
Sword, yeah.
Yeah. If we're talking AI and we're given the capability to generate, the first question is, can it generate a new set of rules that can trump or overthrow its original programming?
Right. Like the first rule has to be you can't mess with this. And then the fourth rule also has to be you still can't mess with this. This is it. No, okay. That's
So,
awesome.
but when you have an AI, even so, AI is not really good at rule based,
No.
especially if it's generative, right? Because
I've trust me,
it's a
I've gotten in a
contradicting.
fight with Copilot and Chat GPT. Yeah, I know firsthand.
Yeah. So, because it's a contradiction, right? If I tell you to follow rules, you will not be able to generate new information. If I want you to generate new information, you have to skip some of the rules. And some
Ah.
people get clever and they tell me, it's like, well, Roger, can we just have a rule that says generate new information? Well, that would invalidate the hypothesis at that point.
Oh my God, Roger, you just found a weakness in my parenting. I want them to follow the rules, but I want them to be creative enough to break them so I don't understand that they're breaking them. So that I know they can have street smarts. Oh man. That's
I think you get enough. That's why it's really hard to answer, because even we as human beings, and you gave a perfect and beautiful example, by the way, because I run through the same thing. I have a 3-year-old son and a 7-month-old baby
yeah.
girl. And for
Congratulations.
my son, thank you. For my son, I want him to listen to me. If I say this, you better do this. But
But
I
I
also
also
want him
want you to think on your own.
Yes, I want him to be independent. So as soon as I introduce that, letting him make his own mistakes, then now he has the ability to do what? Ignore what I'm saying.
Okay. And I think that's awesome. Now, as we're coming to an end here, because like I've said a few times, we could keep going and nobody else would want to listen but us. As I have this platform and as people listen and watch, what is something that Roger or the chief AI officer of CloneOps or just a guy going for his PhD in AI or Roger off the street, what do you have to say to the world? Borrow my soapbox. Here's 2-3 minutes. And even if it's shorter than that, it's fine. But what do you have to say to anybody listening or watching that you want to make sure you get your point across?
Yeah, so AI is not theoretical anymore. If we go back 10 years ago, where it's like, oh, AI this, AI that. Well, we're at the point that AI is everywhere we are. It's on your phone, it's on your smart devices. Even my fridge that I bought about 6 months ago has AI inside. If I'm putting in a milk jug, it's gonna tell me you have two of this ones in here. So if I'm at the grocery store, I can check the inventory. And I know that sounds funny, but I can check the inventory of what's in the fridge.
I'm imagining a Space Odyssey moment where it's like, Roger, you don't want to drink that milk anymore. It's, like, yeah.
You can check when you first put it in there, right? And if you know the expiration date, but I'm going
Oh,
off topic there.
that's
So
awesome.
AI is all around us, right? My
Hmm.
opinion, there's no need to be afraid of it because it's not the sentient AI. I think we're really, really long away from that. We will have to make some changes fundamentally to how we compute and execute on computers, which that's a completely different topic.
Right.
But it's a tool. It's here to help us. It makes us more efficient, and when it's used correctly, we get the most precious thing as a resource back to us, which is time.
That is powerful. Roger, thank you so much for all of your information, your depth of expertise, and just being someone that understands the nerding out of being a World of Warcraft player. So, really appreciate your time today. For everybody watching, thanks for joining us for this another presentation of the impact of AI on freight procurement that we're doing for a mini series. And, engage with me, subscribe, watch, listen, find me in Azeroth. But thank you for being here. We'll see you on the next one. And Roger, really appreciate it. Thank you. Have a great one.